one of the things that I did was a project called Metro Alert. Back before 9/11, 911, the 911 telephone number was available. Atlanta is the center of the world's largest telephone system where you can call another number without going through an exchange. It's, I don't know what it is today, but several million telephones that you can call. That's a local call in Atlanta. So they published this number, I don't know what it was, so that anybody in an emergency could call that number, and this system would determine where the accident or the event was happening, where the emergency vehicles needed, ambulances, fire trucks, police were, and then direct those units to the emergency location. There was a central site where our computer was, and they were connected to several remote sites which had terminals like this one here. This was an ads terminal. It was very popular in the day. And these were dumb terminals. They didn't do anything but receive and send data. But the information was transmitted over 9,600 baud telephone lines. And that was as fast as we could get back then. That's about 10 characters per second. But anyway, we developed the computer system, and this had a unique thing. We used a 910, and it had a disk double write. They were very concerned about safety, so they wanted to make sure, in case there was a disk problem, there would be a takeover. So we did that, and it worked quite well. One other thing we did that was kind of interesting, there weren't any GPS signals or anything like that, so how do you locate a location in Atlanta? Well, they had a very nice hard copy map book. It was a great big thick book like this, covered the whole region. Each page was about 1 square mile of the city. So we took those books, those maps, and digitized every road there manually. We actually broke it into sections and then said, this road goes through A1 and B4 and 75 and whatever. So we did that with some housewives and other people who didn't have anything to do. But it worked quite well. We were able to get an ambulance to the site within a very few minutes. Okay, let's go back. Okay, this is the control data 3100, which was similar to the SDS in 24-bit words and capable processes and everything. We used it for quite a few things. Look at the size of this. If you open this door, it was just a maze of wires going from one place to another. Of course, with today's technology, you don't need the size or anything else like that. The Burrs 3500, as I said, was a business-oriented machine. DBA got into the online banking business. This was in the late 60s, I believe. And it had a good COBOL capability, but not a Fortran. It did have a small disk, and it had magnetic tape and so forth. And it had something called a Micker sorter reader. When you send your checks into the bank, there's a machine there called a Micker that can read those numbers down on the bottom and do the sorting and so forth.
And this is still transistors?
I don't think this was, well, it might have been. It probably was by then, because it really wasn't that big. I think this is the processing unit over here. And that's a tape drive and a card punch and whatever. G635, again, was a pretty good machine. It was called a mainframe at that time. It had an operating system, and it was very compatible with the IBM 7094. Their assembly languages were almost identical. And one other thing about it, it was really developed to use for one of the first time-sharing systems. The Dartmouth time-sharing system was developed in Dartmouth University, whatever. But I was able to use one of these for a program I'll discuss later, and it was an impressive machine. Then the Hewlett-Packard 2100 could have up to 32,000 16-bit words, and these were not byte-oriented. You addressed the whole word. And it supported a lot of languages, Fortran, Algol, BASIC. It had teleprinters. Most all input-output consoles at that time were teleprinters, machines that run at 10 characters per second. They usually had a paper tape punch connected to it. We used this machine for quite a few projects. This is what a punched paper tape might look like. I got this off of the Wikipedia website, so the word punched in here is Wikipedia with a carriage returning line feed. And if you ever worked with paper tape, you're glad that cards came along, and then you're glad that terminals came along, so you didn't have to do any of that. Okay, then, like I said, I went back to Florida State and I used their 6400, CDC 6400, which was a small brother to the 6600, which was what you might call the first supercomputer. It was very, very fast, and the program that I ran on it was a number cruncher. It ran 4 hours on this very, very fast machine, dedicated time, at about 2 o'clock in the morning, if I remember. And here's another 7094. We used one of these. University of Georgia had one that we were able to rent time on to do telemetry data processing. When the Lockheed developed the Titan missiles, and they want to know what happened to the missile right after it happened. So they would get these telemetry tapes, which is all of the data that came back from the missile, put on a magnetic tape, and then we took those tapes and produced plots, hard copy plots, and tabular listings of the parameters in the launch. This is a Titan II being launched, and like I said, we took this data from the telemetry of these. We flew in a small plane from Florida to Athens. I remember that trip well. Forgive me for an aside. We got into Georgia. We were flying along, got into Georgia, and the whole state was fogged in. You couldn't see anything. So we were able to land on a small airport in Milledgeville. It was closed. We almost hit a dump truck or something there. So then we caught a cab or something from there up to Athens, which is another 100 miles or so. So that was, I took commercial air back to Florida. Let's see, let me go this way. Okay, that was PBA. Then a friend of mine and I formed a company called Iron Soliva, and we knew that there was a lot of need for photogrammetric analysis and programming, and so we started this company with that in mind. We eventually ended up with over 35 mathematicians and programmers working primarily for the Department of Defense, and most of it was classified. You remember all of you have a digital camera with a CCD array in it. Well, that was the invention that caused photogrammetry to take off, because then they could put CCD behind a camera and an orbiting satellite. They could take pictures of the ground, and transmit that image to the ground electronically. Before that, they actually used ballistic cameras, airborne cameras, which would produce film or plates. They would the satellites would actually drop that in a package with a parachute from orbit. An airplane would come along and catch that device in the air, in midair, and bring it to some ground station, and then it was taken and processed further later on. But anyway, the CCD was a big step forward, and so our company kind of took advantage of that. We were read on to the project at Rome Air Force Base, and got highly involved with that. Our clients were